Hello, I'm Brian Troncone, and welcome to the ArcsJS Basics course. ArcsJS is one of the hottest libraries in web development today, offering a powerful, functional approach for dealing with events, and with integration points into a growing number of frameworks, libraries, and utilities, the case for learning Rx has never been stronger. Couple this with the ability to utilize your knowledge across nearly any language, and having a solid grasp on Rx and all that it has to offer seems like a no-brainer. But learning RxJS and reactive programming can be difficult. There's a multitude of new concepts, a seemingly large API surface, and a fundamental shift in mindset from an imperative to declarative style. Articles and documentation on ArcsJS are often full of terms that, in the beginning, can make your eyes spin in circles. The good news is, it doesn't have to be this way. In this course, we're going to take a down-to-earth, practical approach to learning ArcsJS. We will tackle this from a perspective that's framework agnostic, heavy on common use cases and comparisons, anecdotes from real-world projects, and examples you can put to use right away. Starting now, we will begin to chip away at the important terms, ideas, and concepts you will need to be productive with ArcsJS. While wrapping your head around ArcsJS can be a challenge, I know it was for me, it doesn't have to be a headache. The productivity and fun you will have as you break through the initial learning curve is something you can rely on for the rest of your programming career. Without further ado, let's get started by examining the issue at hand. Web applications today are becoming more and more dynamic. Users are not only appreciating more immersive experiences, they have come to expect them. But with these highly dynamic experiences comes increased complexity on the front end. Gone are the days where simply reloading the page on state changes is acceptable. As developers, we need to manage a multitude of intermingled UI events, often coordinating updates in real time. One user interaction may affect the state of a component on the page, which affects another, which affects another. Enter in requests for data, saves, updates, and coordinating all these things between user interactions, and before long you find yourself in this sixth circle of callback hell littered with random Boolean flags you once thought would be your guide. How can we bring some sanity to this process? How can we manage the growingly complex asynchronous activity within our web apps in a way that is equal parts reliable, readable, and in turn, extensible? ArcsJS was built with exactly this problem in mind. As part of the ReactiveX family of libraries, ArcsJS builds on the observer and iterator patterns, introducing the observable type to help wrangle this growing complexity. Utilizing observables, you can create streams of data or events from nearly anything. For instance, in the front end, you may have a stream of mouse clicks, a stream of keyboard events, or even a stream of responses coming from a network request or WebSocket connection. These streams, expressed as observables, simply represent data that is sequenced over time. You can then listen to or observe these streams by subscribing, supplying callbacks to be invoked when a new value arrives, an error occurs, or the stream has completed. This is known as a push-based approach. We turn the control of these functions over to the producer of data, in this case, the observable. The observable then pushes the observer data by invoking these callbacks as data arrives. In a way, this is the essence of reactive programming with ArcsJS. Instead of being unprepared and getting hit in the face with data, we define how to react by registering functions to express the flow of data through our streams as it arrives. But while the ability to create and observe streams is the foundation of ArcsJS, the idea of being able to register callbacks for events certainly isn't anything new. For instance, if we swapped out our diagrams with code, we really aren't gaining much using ArcsJS in the first example versus manually adding an event listener in the second. The real power behind ArcsJS is in the built-in operator functions. With these operators, you can filter, transform, and compose your streams in a stateless manner, declaratively expressing the flow of data through your observables. For instance, where an imperative solution to long press events in vanilla JavaScript may feature Boolean flags and scattered timeouts, with ArcsJS it could be expressed declaratively through just a few operators. You can think of operators in ArcsJS as real-time queries as data blasts through your streams. Many of the same concepts and methods you are already familiar with from JavaScript collections can also be applied to observables through operators. For example, where you may be used to transforming an array by mapping over it, you can perform this same operation with observables and the map operator as events occur in real time. Where you're probably already comfortable filtering an array of values, you can also filter events as they flow through your observable using the filter operator. Virtually any action that you can perform on a collection of data synchronously, you can also perform on a stream of events asynchronously with ArcsJS and observables. And this is just the tip of the iceberg. For instance, where filtering on a data attribute may handle certain use cases, there are also operators to filter on time-based criteria, such as pauses in action or sampling on an interval, should the need arise. Where mapping to basic values may fulfill some needs, there are also operators to map to or combine streams should the situation present itself. Nearly any data flow you can imagine can be expressed through an operator or combination of operators with ArcGIS. These operators, or ArcGIS, is often referred to as Lodash for events. But where Lodash's array methods operate on data being pulled out of a collection, ArcGIS's operators let us react to data as it's pushed from the observable to the observer. Utilizing observables and these operators, you can bring sanity and, quite frankly, fun to your front-end development experience, transitioning the flag-littered callback hell we started with into a serene, extensible codebase modeling your user interfaces as a series of streams. And many big companies are doing just that. Originally created at Microsoft, ReactiveX libraries, including ArcGIS, have seen adoption among some of the largest companies in the world, including Netflix, GitHub, and Airbnb. The same observable patterns and many of the same operators you learn with ArcGIS can also be applied across multiple languages and projects. For instance, if you are building an Android app, you could use RxJava, or an iOS app, RxSwift. Once you are comfortable with observables, there is no limit to where you can take them and the problems you can solve. Within JavaScript, some of the most popular frameworks and libraries either feature observable interfaces or include open source libraries that can integrate ArcGIS into your current workflow. For instance, Angular and CycleJS both include ArcGIS support from the start. Within Angular, one of the most popular open source collections, NGRX, features libraries and tooling around Redux-like patterns supercharged with ArcGIS. React integration includes Redux Observable, providing ArcGIS-based middleware for Redux. Vue features VueRx, which introduces better support for observables within your Vue components. Wherever you churn, you can find growing support for ArcGIS and observables within your favorite frameworks and libraries. In this course, we're going to focus on the primary concepts and patterns you need to be successful with ArcGIS, agnostic of any other library. Once complete, you'll be able to take this knowledge and apply it within any ArcGIS charged library or framework you choose, or just use it standalone. You should also be comfortable enough with observable patterns to utilize your new knowledge within Arcs-based libraries and other languages with a minimal learning curve. So, where do we go from here? Well, to begin the course, we're going to dive into the behavior of observables by creating them manually using the observable class. Next, we will see how to use ArcGIS's built-in creation operators to manage this process for us, letting us quickly create observables from nearly any source. Once we have a solid understanding of how to create observables and the essential creation operators you will need in order to be effective, we will spend the rest of the course taking a deep dive into ArcGIS's pipeable operators. Throughout these lessons, we will create and build upon common examples and use cases to see how we can put these operators to use in real-world scenarios. By the end of this course, you will be comfortable with all the concepts and patterns necessary to be effective with ArcGIS and reactive programming. Let's get started.